In this video, let's take a look at some of the properties or design decisions that might go into the development of a network. We'll explore open versus closed, smart versus dumb, and finally we'll take a look at network architectures in centralized versus decentralized. So firstly, open networks and closed networks. So a network may be open or closed in relation to a couple of things. Firstly, access. Is it by invitation only, or is it permissionless whereby anyone can join? But we're actually going to focus on open and closed in relation to innovation. So how are changes or improvements conceived, proposed, and then either accepted or rejected? So closed innovation is the kind of activity that is conducted within an organization by employees or members. It's not simply tinkering out of interest, but it's directed R&D with a specific goal in mind. Maybe that's a new product or the development of some intellectual property. On the other hand, open innovation seeks the best ideas and feedback regardless of where they come from. It's not necessarily profit driven and then may not come with some of the same restraints or pressures. So it's really about building in public versus building in private. Is transparency important for the confidence of the network participants, or is secrecy important to protect some kind of competitive advantage? Now, touching on the concept of open source as it refers to software, that is software that's publicly accessible, can be downloaded, redistributed, and or modified. And that's open in the sense that its source code is a collaborative effort and can be freely inspected by anyone. Now, Satoshi Nakamoto chose to release Bitcoin under a permissive software license. Now, there's a quote I like to use when explaining this that might clarify a few things. I'll read it for you now. It's from a Twitter user, Wizard of Oz, and the handle is BTC Shelling Point. Open source is very much a meritocracy. You've got the hive mind building solutions, and you get all of that scrutiny that comes back to security. Bitcoin Core is probably one of the most heavily scrutinized code bases in the world. So open source doesn't have to necessarily strictly apply to software. It can apply to any protocol that is created or emerges through collaboration and iteration without a central authority that can unilaterally change rules. So a good example of that are languages. They are an open source protocol for written and spoken text, and languages are permissionless in that anyone is free to learn a language and then join the existing network of speakers and communicate with them on a peer-to-peer basis. So there are no gatekeepers, there are no licensing requirements. Messages don't have to be processed or relayed through some central system. And additionally, anyone's free to innovate in that they could propose new words or use existing words in new ways, and other speakers then collectively get to choose whether to adopt or reject those proposals. So at the end of the day, all that matters is, can others understand you? There's no other metric. The next consideration is whether a network might be smart or dumb. Now, the terms smart and dumb, they refer to different approaches in network design and functionality. Specifically, where does the intelligence and processing take place? So does it happen within the network infrastructure, or does it happen on external smart devices which connect to the network? A way to think of that is dumb networks, smart devices, or smart networks, dumb devices. Now, dumb networks focus on transporting data from one point to another. So they rely on the end smart devices to perform tasks such as routing, security, or data interpretation. And this obviously has advantages when it comes to scaling a network. But smart networks, on the other hand, they distribute intelligence throughout the infrastructure to actively manage and optimize data flows. And this means they can cater to dumb devices that do not have built-in processing capabilities. To illustrate, smart networks do the heavy lifting of processing data so that dumb connected devices don't have to, and dumb networks outsource this to smart devices, allowing innovation to happen at the level of the user. Might be helpful to revisit this example, the network of chat telegraphs that has very limited functionality. It can only do one thing, and that is move its adjustable arms to represent different characters. Now, this wouldn't stop a user from being innovative and using it to relay all kinds of information. So, perhaps a secret language, or chess moves, or even a lightning invoice. I'll just read a quote from Andreas Antonopoulos that maybe summarizes all of this. Smart networks offer sophisticated services that can be delivered to very simple end-user devices on the edge of the network. Dumb networks offer only a very basic service and require that the end-user devices are intelligent. Now that quote comes from an optional reading that I'll link to. It's Decentralization, Why Dumb Networks Are Better, an essay he wrote in 2015. So think of a pipe connecting 2 points that offers a passage through for liquid. This is dumb network infrastructure. It doesn't know or have the ability to manipulate what's moving through it. It only cares, or its only requirement is, does it fit? So we're talking about very rigid and predictable functionality here. The last point we're going to touch on is looking at centralized versus decentralized networks. Now, this is relating to the architecture of a network. So do you have one single source of truth or authority, but also one single point of failure? Or is a consensus reached by a network of independent actors, each following and enforcing a common rule set? So it really comes down to, what are you prioritizing? Control or redundancy? So remember this example from earlier, the All Red Line, the network of electrical telegraphs built by the British. Well, while it might not be apparent from this diagram, the network of cables was heavily overbuilt to ensure redundancy during war times. It would actually take almost 50 individual failures, cable cuts, for the United Kingdom to be isolated from the rest of the network. So this is an interesting example that kind of straddles both categories in that it's centrally controlled, but even if the British were to be cut off from the network, operations can continue between any 2 points because it's a dumb network following a common protocol, that of Morse code. So let's take a visual look at what happens when you remove the hub or authority in a centralized network. Well, it leaves all nodes isolated. Now, if we did the same for any one node in a decentralized network, the network can continue to function without them. So what about when a network doesn't just communicate information, but must also perfectly preserve it? Well, this man is Claude Shannon, and he's known as the father of information theory, which is a field of study concerned with this particular challenge. I'll just read a quote now. The fundamental problem of communication is that of reproducing at one point a message selected at another point. You can find this concept explained in a bit more detail in your copy of the Bitcoin Handbook if you're interested. But let's just take the case of a monetary network for the moment. So redundancy of information storage is critical when we're talking about a monetary network. You would never use a monetary network if you weren't certain that the ledger would accurately record your balance each time you connected to it. So that's why Bitcoin's decentralized architecture is critical, and its protocol or rule set enables a network of independent nodes to retrieve, recreate, and validate the entire network history with just one other peer. So last quote before we wrap up, and it's from Satoshi Nakamoto, and the quote is this: "A lot of people automatically dismiss e-currency as a lost cause because of all the companies that failed since the 90s. I hope it's obvious it was only the centrally controlled nature of those systems that doomed them." Here are some of those failed attempts listed below that would offer a valuable lesson to Nakamoto and ultimately help inform the design of Bitcoin as a decentralized network.